Okay, this is day 18 video. It's for Wednesday, April 22nd. We were talking about the probability of a single event occurring, which hopefully you found pretty easy. I didn't get any questions. Please keep them coming if you do have questions. Today we're going to talk about the probability of two events occurring. So I want the probability of A and B occurring. Oops, and B. And that's going to equal the probability of A times the probability of B. Now, that's for what we're going to call independent events. The probability of A occurring is not affected if B occurs, or the probability of B occurring is not affected if A occurs, because B comes second. The other way, we're going to do the probability of A and B. It's going to equal the probability of A, but now times the probability of B given that A has occurred. And this is for dependent events. Okay. And this is the probability of B given that A occurred. Okay, so let's deal with a deck of cards. We're going to draw a card. From a deck. And replace the card. Then pick another card. So I would like the probability of a heart and a queen. So it's not the probability of picking a queen, a heart, queen, not one event, it's two events because the word and is in here. Or of course you could use the symbol and. And that would equal the probability of a heart multiplied by, now is this independent events or dependent events? Well, since I'm going to replace the card in the deck, the second draw has absolutely nothing to do with the first draw, so these are independent events. So I'm just going to multiply by the probability of getting a queen. All right. Now remember, heart, there are three suits. Yeah, there are four suits, each containing 13 cards. So there are 13 favorable events, or ways it can occur, and out of a total of 52. The probability of a queen, well, each suit has a queen, so there are four, and there's a possibility of 52 cards. Now we just need to reduce this fraction down. 4 over 15, running out of room here, so just going to go sideways. 13 out of 52 is 1 out of 4. 4 out of 52 is going to be 13. Oh, the 13 doesn't go on the top. The 4 reduces to 1, and 4 goes into 52 13 times, so it's going to be 1 over 13, or that's going to be 1 out of 52. Okay? So now if we draw a card, from a deck, then pick another, and it doesn't say replace. So if it doesn't say replace, This is without replacement. So it has to specifically tell you that it's replacement. Now let's find the probability of a heart and, oops, don't separate them yet. So we get the probability of a heart and a club. Now, we are dealing with dependent events. So this is going to be the probability of a heart times the probability of a club given a heart has already been drawn out. All right, so the probability of a heart, there are 13 hearts out of a total of 52 cards. Now, we do not replace that card, so that heart is gone. So I'd like to find the probability now of club given a heart. So how many clubs are in the deck? Well, this card that we pulled is a heart. So it does not affect the clubs. There are still 13 clubs in the deck. But I don't have 52 cards. I'm down to 51 cards. So we're going to keep reducing this. This is going to be 1/4. And I believe that's all the reducing that can be done. So that's going to be 13 over 204. Okay, do one final example here. We're still going to draw a card from a deck, then pick another, and again, we're going to assume without replacement. I would like the probability of the ace of spades and the probability of an ace. So we're going to pick a card. We're going to get the ace of spades first, and then we want the probability of getting an ace. That's going to be dependent events. So we're going to have the probability of the ace of spades times the probability of an ace given the ace of spades has occurred. The probability of an ace, well, the ace of spades rather, there is only one ace of spades in the deck, and there's a total of 52 cards. Now I want to pull out another ace given the ace of spades. Well, 4 total aces, but 1 is gone, so I'm down to 3. And not 52 cards anymore because I've already pulled a card, the ace of spades, so I've got 51 of them left. The 3 and the 51 will reduce to 1 over 17. So that's going to give me 1 over 884. And I didn't do it with the other twos, but that's going to be 0.0011, which would be 0.11%, 1/10 of 1%. All right, guys, I think that should get you going. Check Google Classroom, keep the questions coming, and enjoy it.